So I'm Shokhrukh Umriyaev from booking.com, and here I'm going to talk about how we use GraphQL in backend for service-to-service communication. But before that, let's talk a bit about booking.com. So it started in 1996 as a small startup, and nowadays it's one of the largest online travel platforms, offering a wide range of travel products, starting from accommodations, transport, flights, attractions, and many. Our mission is to make it easier for everyone to experience the world. And we are a global travel industry. We provide to our travelers a wide range of travel products, and at the same time, we cannot do that without our partners, to whom we are partner to millions of entrepreneurs of all sizes that use our platform to promote and sell their services. Our vision for the future of travel is to leverage technology to make it easier to experience the world. And our search results page, which I think a lot of people here are familiar if you use booking.com or ever used it. It's a stark example of how we are making that vision a reality. So in order to render this page to millions of our users with the lowest latency possible, with highest availability possible, we need to query a lot of content stored in hundreds of databases. We cannot query all of them in real time because from the tech interviews or systems interviews, we know that it would be very costly, or we would need we would have very low availability. So what's the answer from system design questions? Caching. So we pre-materialize data in background, and then for our search results page, it's mostly like key value and lookup for each of the accommodations which need to be displayed on the search results page. Previously, it used to be a monolithic service with materialization component, which would query all these data sources, which it doesn't own, apply some business logic on top, and put it on a monolithic schema, and publish if there are any updates detected to our update stream on Kafka. And for our search results, we have a bare metal backend, which had two important threads, request handler thread and update consumer thread. And this bare metal box was being shared between two very important threads, and the update consumer was consuming the updates from update stream and putting it in a RocksDB storage, and then the request handler was using that RocksDB storage, which is in-memory database, to serve the data to our customers in lowest latency possible. But the problem is, there are several problems. First of all, this is a bare metal setup where this disk and memory I/O are shared between two very high frequency threads. So because we have thousands of fields in our materialized data schema, when any of those fields change, regardless of if this search results backend is interested in those fields or not, they still receive updates through the update stream, which creates enormous load on the disk, because RocksDB is both disk and memory intensive. And then it caused us availability issues multiple times in the past. So, like I said, we have hundreds of databases being queried by a monolithic service with a monolithic schema being pushed to the update stream, which is used by many different consumers through both Kafka topic and through API. So, we don't have any separation of concerns here, or we don't. So, both business logic and data retrieval logic were mixed in the same code base in the materialization service. We didn't respect ownership boundaries. So all of these data sources are owned by different teams across the company, and this service was querying all of those directly from the data source. And then it was a monolithic schema and monolithic service, which was shared between many different consumers. So, what could we do? Back in 2019, Booking.com, together with Apollo Studio, started working on leveraging GraphQL to modernize our front-end architecture. So we were moving towards micro frontends to use GraphQL for interoperability between front-end and back-end. It's not news to anyone, right, to use GraphQL for that. But then we thought, like, could we use GraphQL for backend service-to-service communication? Because our use case matches the use case of GraphQL. Like, we are connecting different schemas, different models together into a big super schema. But the only problem for using GraphQL in backend service-to-service communication is it causes very high latency compared to, for example, protobuf. Right? So serialization is way slower compared to protobuf. But for us, because as I mentioned, batch materialization or materialization process is an hourly process. It happens in the background. Latency wasn't an issue. For us, the trade-off between latency and what we would get from the GraphQL, which is observability for which fields are being used where, by whom, and also a single, like, centralized, standardized API, which is Graph API, it was a better trade-off for us compared to latency, because we didn't care much about the latency, because it's a background job. None of the real-time requests would cause any requests to this backend. So, like I said, the materialization happens hourly, so for us it was fine. So we decided to use GraphQL for this use case. In the high level, it looks like this. From from schema perspective, we have many data services who define their schemas. Then they publish it to the Federation gateway. It stitches those schemas together into one supergraph, published to our clients. Then our clients send GraphQL queries to the Federation gateway, which in turn orchestrates data fetching for each requested part of the query. If we go into detail, so now we have subgraph services in front of each of the data domains. Like, we have hotel data subgraph, we have review score subgraph, room subgraph, photo subgraph, which are then stitched together into a supergraph on a materialization federation gateway layer, which then is queried by search results materialization service. And it stores the results after applying some business logic to the Cassandra storage, and then materialized data API service works as an API on top of this data, and search results backend is now stateless because this data was moved outside, so that we could also move this bare metal component into containerized Kubernetes environment. Moreover, we are now respecting the ownership boundaries. So hotel data subgraph service lives and owned by the same team which owns the hotel data. Same goes for review subgraph. And for the search results team, they own the entire ecosystem of serving the data to the customers through the search results page, and also preparing that content for them to serve it in lowest latency possible. And then the materialization federation gateway is in between, connecting all those parties together and doing an awesome job. So in example, like I said, so there is a rooms data source, there is photos data source, facilities, etc. All of those data domains, they can define their own GraphQL schemas, as Yuri also mentioned. And on the federation layer, we converge them into one super schema. And then this way, we can allow the accommodation details page content materializer to request only the fields they need, which is photos and rooms, for example. Search results page content materializer to request for main photos and facilities, which is what they need to display the search result cards, for example. So we allow those many different use cases, and they are only querying the fields they need. They are only materializing and caching the fields they need. And at the same time, they are not breaking the ownership boundaries. They are talking to the materialization or GraphQL layer, like through a centralized GraphQL service, which in turn is taking care of providing a centralized API. So now we are respecting the ownership boundaries because now we have microservice environment where ownership boundaries of all the components are respected. We get observability out of the box because Apollo Studio provides us field level usage observability, not only on the field but also on the subgraph level. And previously our materialization component was tightly coupled to only accommodation data. But now this platform can be used for all the travel products we have, including flights, car rentals, attractions, taxis, and also different types of accommodations. Thank you very much. This was me. I'm not sure if we have time for questions. So, if there are any questions? Yes?
So how long did it take to convert to this platform, and how many people were involved?
So this took about half a year for 2 teams, because this was new and we had to rewrite many data fetching logic into GraphQL. But after the first big use case, onboarding the second use case took less than a month, for example, because we already had many data sources available. And then, they could reuse a lot of things already.
So 2 teams of what?
Two teams, like 2 platform teams. This is a backend system, so search results backend team and materialization ecosystem team. Yes.
Booking is well known for its data-driven experimentation platform. How do you handle experimentation with pre-materialized data?
So, very good question. So, in order to migrate the search results page from the old materialized view into the new materialized view, we ran A/B testing on the page level. So we had 2 sources of materialized data, and then on the page we were doing coin flip, and based on the result we were showing either the old view or the new view. In the new setup, after this showed us that our latency increased only 20 milliseconds, which is very good considering that we are replacing in-memory access with network access. But at the same time, so this search results backend, it has very good experimentation tracking capability. And what they do usually is they create experiment fields and not base fields in the GraphQL schema. And based on the experiment results, either they fully migrate to the new field and clean up the old field, and vice versa. The good thing about GraphQL and from observability perspective as well, like as I mentioned, previously with Protobuf, we also were doing that, but we didn't have, as a platform team, we didn't have any way to monitor if the experimental fields are still used or not. But with GraphQL, now we have this capability. Any more questions?
Yeah.
Yes?
Yeah, is the API for companies outside of Kuwait, is it also converted to GraphQL?
Not at the moment. We don't, maybe, no, well, we don't have any GraphQL. No, not at this moment, but if you have any recommendations or questions, maybe you can reach out to the contact information. Any more questions?
Do you have any learnings from this
I mean, because it involved interaction between two teams residing in two different departments. Of course, in the beginning it was a bit challenging, like to scope out the problem, like to get buy-ins. But because we all were working towards the same goal, like the search results backend, they wanted to containerize their bare metal service. And we wanted to like replace the monolithic architecture with more like microservice architecture based on GraphQL. We were able to find a common ground, and we worked together after that. So it was easy. Yes.
Why you choose federations teaching versus the guilds teaching?
Because in versus guilds teaching.
Yes, they can provide another way of teaching.
Okay, so in our case, like I mentioned, back in 2019, we already started using Apollo Studio, and we decided to like reuse most of the things. Yes. I think I am out of time, right? Thank you.
And now we have Marian from Mazura with a bit of a spicy talk. GraphQL with